All right, so let's do the warm-up, and then we'll go over the homework stuff. It says, let the graph of G be a translation 4 units left. Okay, so we'll do that first. All right, so the original is right here. So remember, wherever there's an X, we have to put what if it's 4 units left, sorry. What did you say? Plus 4, good. So you know. You told me you didn't know. So, we'll do it in red, the first step. So where the X is, like Cindy said, go X plus 4. Okay? That's a horizontal movement, right? That means we're changing the X. Because which axis is horizontal? The X-axis, okay? So, we did a little shortcut yesterday. I showed you, when you do squaring a binomial, square the X, multiply those two together, which is 4X, and then what? There's 2 of them, right? There's 2 4X's, so double it. So you just go X times 4, 4X doubled is 8X for the middle term, and then square the 4, which is 16. And then we got the X plus 4 still. So combine like terms, again, this is just algebra 1 stuff. 8X plus 1X is 9X, and 16 plus 4 is 20. So that's the first translation, or transformation, I guess. All right, the next thing we're doing is a horizontal shrink. We call it a compression, right? By a factor of 1/3. When it's horizontal, what do we do when we get those factors? Spencer? Reciprocal, right? So we're going to go 3 times the X part. Again, it's horizontal, so we're changing the X. So we're putting a 3 in here for 3X for the X part. Again, for the horizontal stretches and compressions, whatever factor they give us, we're using the reciprocal. Okay? So, what's 3X times 3X? Louder. 9X squared, right? And what's 9 times 3X? 27X. Okay? That's all we had to do, right? We had to do 2 of them. So that's my final answer. My G function now is that. That's what we were supposed to do. Okay? Now, you were supposed to also on your homework, it said find the vertex. Okay? Which we'll show you on the homework problems if you need me to. All right? So, 28, just describe the transformation of the graph, then identify the vertex. Okay? Yesterday we talked about vertex form. Again, this is review from earlier in the year, but, vertex form is this. The vertex is HK, those 2 numbers. Okay? So, let's just do the vertex part real quick. What makes that equal to 0? 1, right? Or, and it's X minus 1, which way are you moving 1? Right 1, right? Where does the parent function vertex for parabolas, for quadratics, always start? At 0, 0. So this says to move it right 1. So what's 0, right 1? Positive 1, right? What number's out here? What k value's out here? What do you see? You see nothing, right? What is nothing? 0, yeah. So my vertex is 1, 0. Okay? So if there's no number plus or minus out here, the y value of the vertex is 0. Okay? And we're supposed to tell the transformation. Okay, so we moved it right, 1. You guys already told me that, right? And what's this 1/2 times the whole thing mean? Is that a vertical or horizontal? That's a vertical. Is that a compression or a stretch? Compression. By 1/2. Okay? Remember, it's vertical, it's whatever they tell us. When it's horizontal, it's the reciprocal. Okay? So, that's how you do 28. And again, you should be able to look at it now. Any questions on those 4? Looking at what I had. You still want me to go through any of those? Yes.
I have a question about 31. So
Okay. Listen, please.
When you give us the answers, you turn to a 1/2 into a 1/4. Well, I don't know
Yeah,
why.
okay, because we did a horizontal stretch, right?
Yeah.
By a factor of 2. Since it's horizontal, we're actually going to multiply the x by 1/2, right? So what we do is, for the first step there, we have the 8, and then it's 1/2 times the x, and then x spot, and then there was no other x, so it's just minus 6, right? Well, when I simplify this, clean it up, do I do multiplication or exponents first? Exponents, right, Aunt Sally? Please excuse my dear answer, right? Excuse is for exponents, M is for multiplication, right? So we do the exponent. So what's 1/2 times 1/2? What's 1 times 1? What's 2 times 2? And then squared, so. And then I could go 8 times a 4. What's 8 times 1? 8 divided by 4, 2. So this becomes 2x squared minus 6 when we simplify it, when we clean it up. That's what you wanted, right?
Yeah.
Okay. You're welcome. Anything else? Let's just go ahead and finish that one. And then 2 units up and down vertical, we just put that on the end, right? Up is plus 2, right? So when I simplify, I got 2x squared minus 4. Then we have a reflection, I wanted to do red, sorry, in the y. All right? So when we reflect the y, we change the x to its opposite. So wherever we see x, we put the opposite of that, which is negative x. All right? We only have the x in that one spot. So I got 2, and then I make x negative x squared. When I simplify that, what's negative x times negative x? Positive x squared. So it comes out to be the same as the blue one. So that's the final. Now, you were supposed to, I think, identify the vertex, right? So since there's no x minus anything or x minus 0 squared, that's the same thing, right? X squared and x minus 0 squared is still x squared, right? So what's my vertex? What's my x value? 0. What's my y value? Negative 4. Okay? So the vertex is 0, negative 4. So if there's nothing in parentheses that's being squared, that means the x value of the vertex is 0. Questions? Others, homework-wise? Is that helping? All right. So today, part 2, properties of parabolas. We already talked about this year. What is that axis of symmetry? Where does it go? Right down the middle of the parabola, right? Right through the vertex, correct? Remember? And we always make it a dashed line. It's a solid red line now. But when we graph parabolas, that one quiz we had, I asked you to put that dashed line in there, remember? That was our axis of symmetry. Again, here's our, oops, that's not what I wanted. Here's our what form? Vertex form, right? Because we can look at it when it's at, to find the vertex, okay? So once we know what the vertex is, this number and this number are the same. So whatever the x value of the vertex is what x equals for the equation of that vertical line, for that axis of symmetry. Okay? It's always an equation for the axis of symmetry. X equals whatever the x value of the vertex is. Okay? Okay? So it says previously you used transformations to graph quadratic functions in vertex form. You can also use the axis of symmetry and the vertex to graph quadratic functions written in vertex form. Okay? So let's look at a couple examples. All right? Graph each function, label the vertex and axis of symmetry. So let's just do that part first and then we'll graph it. All right? So the vertex is what? -3, +4. So -3, +4. There's the vertex. Does this thing open up or down? Down, right? Because that negative sign means it did what? Flipped it or reflected it about the x-axis. Right, Landry? Right, Cindy? Okay? So if I know that the vertex is -3, 4, what's the axis of symmetry? X equals what? -3. All right? So here I'll use it, make it a nice one. I want it to show. There we go. So there's my axis of symmetry. Down through the vertex, right? So what do we call, whoops, I gotta get off of that. Get back to my pen. All right, so this is the AOS, right? And there's my vertex. So I did those two things. It also said we should graph it now, right? So what I would do, since our vertex is moving around, okay, is just pick the two numbers. If the axis of symmetry is left of 0, pick the next two numbers that go towards 0, to the right of it. If your axis of symmetry is over here, going through the first and the fourth quadrant, right of your 0, 0 point, then go left those 2 points next. And make just a little XY table. So what's this X value here where the axis of symmetry is? Come on. -3, thank you. So what's this X value? -2. What's the next one to that? negative 1. And all I'm going to do is substitute it into the problem to find these two y values. Okay? So when I put negative 2 here, what's negative 2 plus 3? 1. What's 1 squared? 1. Times negative 2. Negative 2 plus 4. So negative 2, 2 is one of my points. I can just reflect it because it's symmetrical, right? So here's another point. Negative 4, 2. All right, put negative 1 here. What's negative 1 plus 3? 2. What's 2 squared? 4. Times negative 2. Negative 8 plus 4, negative 4. So then at negative 1, it's negative 4. And then just reflect it. Is that, and this is a vertical what? Since it's a not, a whole number, a number bigger than 1, I guess. It's a stretch, right? Did it make it skinnier from the parent function? It is a little skinnier, isn't it? Okay? Questions on how we graph that? So just do a quick little oh, sorry, I didn't put that in here. Just a little 2-point XY table, and then just reflect, across that axis of symmetry. Because it's symmetrical, right? Isn't that what we did before? We used the y-intercept before, didn't we? And then we just reflected it from there. Questions? All right, let's do one more example. All right. So since this is 0.5 times the whole thing, it's a vertical compression. So it's, vertical is this way, so it's making it a little wider, right? Shorter. This means we're moving which way? Left 4 and down 2, which means my vertex is negative 4, negative 2, right? Negative 4, negative 2. There's my vertex now. Does this thing open up or down? Did it get any reflection? Going up, right? What's my axis of symmetry? X equals negative 4, whatever the x value of the vertex. Okay? So I'll draw in my axis of symmetry through my vertex. Okay? So I'm going to make my XY table. I'm going to go towards the y-axis. So what x values there? Negative 3 and negative 2. All right. So what's negative 3 plus 4? 1 squared. 1 times a half. 1/2 minus 2. Negative 1/2, right? So negative 1/2. Right there, isn't it? And just make it reflect across there, right? What's negative 2 plus 4? 2 squared. 4. What's half of 4? 2 minus 2. So negative 2, 0, so negative 6, 0. So is that a little bit wider than our normal parent parabola? Moved left 4 and down 2, right? Making sense? All right. Let's do some homework. These three are just like the two examples. These 4 are just matching. They do the graphs for you. You're just matching the graph with the function, the equation.